In this video, we are going to talk about the hash table and learn how to code one. The hash table is a data structure that is used to store data in the form of key-value pairs. The data that is already stored in the hash table can be fetched by using the key as a reference. This is why hash tables are commonly used as lookup table data structures, because they are really fast and reliable when storing key-value pairs where quick lookup is required. Before we get into the tutorial, I would really like it if you subscribe to the channel and consider supporting it. All of the content that I produce here is free and I would like to spend more time creating it. Your contribution will go a long way in making sure that that goal is achieved. Links to support the channel are in the description. Let's go. The hash table is usually an n-dimensional array. Particularly, in our case, we are going to consider a hash table that is a one-dimensional array. The way the process of filling up the hash table with key-value pairs works is very interesting. The function that fills up the table is called set. It takes the key and passes it through a hash function. This hash function is special in the sense that it is a hash function that returns a number. Also, it's not just any number, but it's a number that is actually in the range of 0 and the length of the hash table. Our hash function basically returns the index of where our key-value pair will actually be stored. There is a caveat to this though. The size of the hash table is not infinite, as you will soon find out. What if the hash function returns the same index for two different key-value pairs? Which of the two key-value pairs will be given a spot in the hash table? The phenomenon that would occur in this case is called a collision, and collisions need to be dealt with. There are many different ways of dealing with collisions in a hash table, but the one which we are going to use in our code is called chaining. Particularly, chaining with a linked list. Just to be clear, I am assuming that you already know what a linked list is and how it works. The idea here is that each of the buckets or cells of the hash table are actually full-fledged linked lists. When you store a key-value pair now in the hash table, instead of the key-value pair being stored directly inside the cell, it is actually being appended to a linked list which in turn lives inside the cell. It's not just the value that's being stored, but the key-value pair is treated as a unit and appended as a whole towards the end of the linked list. A better hash function is always going to cause fewer collisions. A bigger table is again going to cause fewer collisions. With that said, let's take a look at the code. Let's start with the import statements. The first thing that we import is the hash function that we will be using to generate our own special hash function, which will give us a number. Next, we are importing the linked list data structure that we require to properly implement the hash table. No, we are not faking anything here. We actually implemented the linked list for the purposes of this video. You can find the full source code for the linked list in the description below. The default hash table size is the default size of the hash table if there was no explicit size passed in while constructing the hash table. This is the number of cells or buckets that will make up our hash table. The default size is kept to 32. Next, we define our hash table class. One thing that I want to mention here is that, yes, we could have done all of the implementations without actually defining a class and importing the linked list, but I don't think it would have done justice. The beauty of software engineering, where code comes together like building blocks, is just majestic. The constructor, with no surprise, takes the parameter of the hash table size, and as we said previously, if no size was explicitly passed, the default size is assumed. Two member variables are defined in the constructor. The first one is our hash table itself, which is called buckets, and the other one is keys. Buckets is defined as an array which is of the length of the value of hash table size. This is because the buckets array is our one-dimensional hash table. The keys member variable is defined as an empty dictionary. All of the reason that keys exists can be implemented without actually using keys, but this just provides a quick lookup for the functions has and getKeys, which will be implemented later. Yes, keys might as well be another hash table, but let's not get adventurous. The most important function or method, whatever you prefer, here is the set function. On the first line of the implementation on the set function, it passes the key, from the key-value pair that was sent to it, into our custom hash function. If we scroll down to this hash function, we can see that it is a peculiar sight. The key is converted to a string, if it wasn't already, and encoded explicitly into UTF-8. Then we call the hex digest function on the MD5 object, which gives us the MD5 hash string. Then again, we pass the string into the global function list, which converts the string into an array of separated values. Traversing over the array with the for loop, we convert each character value into its code point integer and accumulate that in k. This gives us an integer value that is unique to the key we passed in. But, this number is way bigger or smaller than our actual hash table size. So, mod it with the length of our hash table. The modulus operator gives you the remainder of the division operation. The remainder is always less than the value you divide by, and this serves our purposes. Coming back to the set function, the key hash now has a number that is in the range of 0 to the length of the hash table. As we want to use keys as a quick lookup, we store the value of the key hash in the keys dictionary with the key as the identifier. The key hash is the index of where in the hash table the key value pair will be stored. The next line fetches the bucket from the hash table with the index key hash and references it with a new variable called bucket linked list. Before we put anything in this bucket, which is actually a whole linked list, we need to make sure that the same key does not already exist in the linked list. If it exists, we need to update the key with the new value, and if it doesn't exist, we need to append the key value pair to the end of our linked list. The get and delete functions are pretty similar. You start off by using the hash function to find which bucket the key value pair is stored in. Once you get that bucket, you implement a custom linked list find which goes through the whole linked list. If it finds the key value pair you're looking for, you can either return the value if you are in the get function or delete it if you are in the delete function. The has function returns a true if the key already exists inside the hash table. This can be implemented without the use of our keys dictionary and by writing a custom linked list implementation as we did earlier. The keys from the keys dictionary are extracted in a list, and we check if the key that the user wants to find is actually in it. If it is, return true, else return false. The get function extracts the keys from the keys dictionary as a list and just returns all of it. We hope you understood the power and also the imminent limitations of the hash table with this video. Please subscribe to the channel and like the video if you liked it. Dislike the video if you didn't. Consider supporting the channel if you want us to produce more content with the links in the description below. Thanks for watching, and I will see you in the next video. Peace.